So today I'm gonna start a new topic of the first chapter, and I think you have heard this topic, which is stoichiometry. Are you aware of this term, stoichiometry?
Yes, sir.
Okay. You see, what this topic is very important, and I'm going to explain this with the help of an example. Let's take an example of a reaction CH4 plus O2. This is your hydrocarbon, and hydrocarbon is the one in which hydrogen and carbon is present only. And when they react, then you will be getting carbon dioxide plus water. The product is constant carbon dioxide plus water. And this reaction or this process is basically exothermic process. That means heat will be released during this process. Rabia, are you there?
Yes, sir. Good evening.
Good evening. We just started a stoichiometry, and I'm going to explain this stoichiometry with the help of an example equation. So first of all, whenever we are going to talk about mole concept, there are two concepts in physical chemistry. The one is mole concept, and another one is equivalent concept. Equivalent concept. So see, what is this mole concept? In mole concept, basically, you need to balance the equation always. You need to balance the equation always. And in equivalent concept, we don't need to balance. We only deal with the n factor that you will study in. You have studied this in solution as well, normality. Basically, we don't need to balance. But whenever you are dealing with mole concept and you are solving any question of physical chemistry with the method of mole concept, then you have to balance the equation. Okay, so first of all, if I'm going to balance, I'm going to put 2 here, and you can see 4 oxygen is there now. So I'm going to put 2 here, and now it is balanced. Now, how you are going to study this? So in class 10th, you have studied about the coefficient, right? You know what is coefficient, both of you.
Yes, sir.
So basically, if I'm going to ask you 2x cube, what is the coefficient of x cube?
3.
No, that is your power. 2 is the multiplied constant in a variable is called the coefficient. This 3 that you have told me, Rabia, is your power. So I asked what is the coefficient of x cube or x raised to the power 3. So the multiplied number is 2. So this is your coefficient. If I'm going to ask what is the stoichiometric coefficient of x raised to the power 2, x square, what will be the coefficient? 2, 1. 1 is the coefficient. In chemistry, we call it a stoichiometric coefficient. In chemistry, we call it a stoichiometric coefficient, basically the multiplied number. If I'm going to ask you what is the stoichiometric coefficient of H2O, so 2 is the stoichiometric coefficient of H2O. What will be the stoichiometric coefficient of CO2? Ravia, you are going to answer this. What is the stoichiometric coefficient of CO2?
1.
Very good. What is the stoichiometric coefficient of O2?
2.
And what is the stoichiometric coefficient of CH4, Aisha?
1.
1. So basically, this stoichiometric coefficient represent your number of moles. We take it as number of moles. This represent number of moles. I'm going to write the equation again, and I'm going to explain this. So as you can see, the reaction was CH4 plus 2O2 that reacts with each other to give you CO2 plus 2H2. This was the scenario. Now, how I'm gonna read this? So here, the stoichiometric coefficient is 1. So what I told you, this stoichiometric coefficient, we are going to treat this as mole. So I'm going to write 1 mole of CH4. You know, CH4 is reacting with oxygen, dioxygen. So 1 mole of O2 reacts with, what is the stoichiometric coefficient 2? So we can write 2 mole of O2. Now, this arrow shows what? This is giving the product. To give, again, we can write 1 mole of CO2 and 2 mole of H2O. 2 mole of H2O. Are you getting my point, everyone?
Yes,
Yes,
sir.
sir.
So see what happens. There are four uh, different things that is given. 1 mole, you can easily see 2 mole, 1 mole, 2 mole. And with the help of this mole, you can easily calculate the mass, because you know number of moles is equal to given mass upon molar mass. Wait a minute. Are you able to see the screen?
Yes, sir.
So you know that number of moles is equal to given mass upon molar mass. If you want to calculate the mass of H2O produced, you can easily apply this formula. You can see the number of moles of H2O is 2. So you can write here 2. Mass you need to calculate, and molar mass, you already know the molar mass of H2O is 18. So mass uh, produced will be 36 gram. Is that clear?
Yes, sir.
Now, we are not going to stop here only in terms of mole. We can also answer in terms of number as well. You know that 1 mole is equal to Na. So we can write Na number of particles or Na molecule, because 1 mole equals to Na molecule of CH4 reacts with 2 mole. 1 mole is equal to 1 Na. So 2 mole is equal to 2 into Na molecule of O2 to give how many 1 mole again. So Na molecule of CO2 and 2 into Na molecule of H2. Are you getting my point? This is all related, because you know that 1 mole is equal to Na, so 2 mole will be equal to 2 Na, 3 mole will be equal to 3 Na. Are you getting my point?
Yes, sir.
Okay, can I change the slide?
Yes, sir.
Okay, let's say if I'm gonna take an example, CaCO3 is heated, CaO plus CO2. Now, if I will tell you 200 gram of CaCO3 is heated, calculate the mass of CO2 formed. CO2 formed, or it can be asked, calculate the mass of CaO formed, calcium oxide, or carbon dioxide. So whenever mass, number, or volume, whatever is given, what you need to do is very simple. You need to calculate number of moles first. As you know that this is 200 gram given, and it has been asked, calculate the mass of CO2. So whenever mass, volume, or anything is given, you need to convert this into number of moles. Number of moles, you know that given mass upon molar mass, and given mass you can see is 200 gram. And if you are going to calculate the molar mass of CaCO3, it will be 100 grams. So you will get 2 mole. Are you getting my point?
Yes, sir.
Now go to the balanced equation, the primary equation, and see whether it is balanced or not. So let me know whether this equation or this reaction is balanced or not. What do you think? Is it balanced?
No.
No. Oh, Rabia, did you say no?
Yes, sir.
Okay. Okay. Look at this again. Aisha, what about you? What do you think? Is it balanced?
Yes.
Yeah, Rabia, you can see that one calcium on the left hand side, one calcium on the right hand side, one carbon on the left hand side, one carbon on the right hand side, three oxygen on the left hand side, one plus two oxygen, three oxygen on the right hand side. Isn't it balanced?
Yeah, sir.
Now you can see. Very good. How many moles react or heated to give how many moles of CO2 in accordance with the balanced equation? So you can see 1 mole of CaCO3, how you are going to read it. 1 mole of CaCO3 gives 1 mole of CaO and 1 mole of CO2. Yes or no?
Yes, sir.
According to the balanced chemical equation. But what we have originally, we have 2 mole of CaCO3 calcium carbonate. We have 2 moles of CaCO3. Yes or no? If 1 mole of CaCO3 will give 1 mole of CO2, so 2 mole of CaCO3 will give 2 mole of CO2. Yes or no? Rabia, are you getting my point?
Yeah, sir.
Now you can easily calculate the mass. Number of moles is equal to given mass upon molar mass. Number of mole is 2. Given mass, we need to calculate molar mass of CO2 is 44. So mass will be equal to 88 gram. And accordingly, you can calculate the mass of CaO as well. How you are going to do it? You can see 1 mole of CaCO3 will give 1 mole of CaO. So actually we have 2 moles. So this will also form 2 mole. Again, N is equal to given mass upon molar mass. Number of moles 2, given mass you need to calculate molar mass. Calcium has 40 and oxygen has 16, so 56, and mass formed will be 112 gram. So it's very easy. What you need to do? Focus on the reaction, balance it. And whatever is given, you need to calculate the number of moles first. And then compare with the balanced chemical equation. What actually gives, what it means is how many moles of reactant is giving how many moles of product, and accordingly you can apply the unitary method. This was very simple because 1 mole was giving 1. There are lots of reaction in which it will vary, like 1 mole will give 2 mole or 2 by 3 mole or 3 mole, whatever is the situation. According to that you need to deal with. Okay, so please do write it. I'm going to give you a question of this, which has been asked in 2019 NEET. You just need to, and if you don't know the reaction, please do let me know. I'll write the reaction for you. Are you done with this?
Yes, sir.
Okay. Let me know, will you be able to write a reaction for this Haber's process to prepare ammonia? Will you be able to write the reaction, Rabia and Aisha? Are you able to solve this?
No, sir.
No, no problem. Have you written the reaction at least?
Yes, sir.
Okay, just wait a minute. Okay. Okay, see, first of all, you need to write the reaction. So how you are going to write the reaction to produce ammonia? You know that hydrogen molecule required to produce the number of moles of hydrogen molecule. You need to calculate the number of moles of hydrogen molecule required to produce 20 moles of ammonia through Haber's process. So what is Haber's process? When nitrogen reacts with hydrogen, there are some catalyst and temperature as well, but we need to prepare this NH3. So in order to balance it, I'm going to put 2 here so that nitrogen is balanced, but hydrogen on the right hand side is now 6. So I'm going to make the hydrogen number of hydrogen 6 on the left hand side as well. Now the reaction is balanced, yes or no?
Yes, sir.
Now you are going to compare what is the stoichiometric coefficient of N2? Isn't it 1? 1 it is, yes or no?
Yes, sir.
Yes, sir.
And the stoichiometric coefficient of H2 is 3. That means, and the stoichiometric coefficient of NH3 is 2. So what you need to keep it in your mind, 1 mole of N2 react with 3 mole of H2 to give 2 mole of NH3. This is what you will read. Now, what you need to do, in the question it is given that the moles of ammonia is 20. The moles of ammonia is 20, and you need to calculate the number of moles of H2. Are you getting my point? It just reversed it. You can see 3 moles of hydrogen will give 2 moles of ammonia. Are you getting my point? You don't need to deal with this now. Aisha and Rabia.
Yes, sir.
Now, I can also say, since we need to calculate the moles of hydrogen, so I can also say 2 moles of NH3 will give you 3 moles of hydrogen. Yes or no? Just like in 5 rupees, if you are in 3 rupees, if you are getting 2 chocolate, that means 2 chocolate will cost you 3 rupees. Simple. So 3
Yes.
moles of hydrogen will give you 2 moles of NH3. That means 2 moles of NH3 will also give you 3 moles of hydrogen. Now, 1 mole of NH3 of sorry, it's sometimes lag or hang the system. Okay. So are you able to see the screen now, right?
Yes, sir.
Now you can see 2 mole of NH3 is giving 3 moles of H2. Now 1 mole of NH3 will give 3 by 2 moles of NH3. H2, it's the unitary method. Now, how many moles of 20 moles? 20 moles of NH3. That will give you 3 by 2 into 20 moles of H2. In this way, you can easily calculate it will be 30 moles of H2. So the answer is your C. Just look at the question and please do understand. If you have got any problem in this, just let me know. Let me know when you're done
Done,
with this.
sir.
Thank
Just wait a minute.
Recording in progress.
I'm going to give you another question. This question is also similar. Is that question? Yeah. You just need to write the reaction and then find the number of moles if it is not given directly. The good thing about the previous question was that it was written. Basically, the number of moles directly were given. This is the question. Will you be able to solve this? Option A. Is this Rabia? Aisha, have you got any answers? So
you.
first of all, okay, I'll just check it. First of all, H2 is mixed with Cl2. The moles of HCl formed. You know that if you are going to mix H2 with Cl2, then HCl will form, right? Now you need to balance it. Two hydrogen on the left, one hydrogen on the right. So 2 HCl it will be. Now it is balanced. Now, as you can see, 1 mole of H2 reacts with 1 mole of Cl2 to give 2 mole of HCl. Now, in the question, it is given that hydrogen is 22.4 liter. Hydrogen is 22.4 liter and Cl2 is 11.2 liter. 11.2 liter. Now, whatever is given, you need to first calculate the number of moles. So if you are going to calculate the number of moles of hydrogen, 22.4 liter divided by molar volume. So the number of moles of hydrogen here will be 1 mole, and accordingly number of moles of Cl2 will be 11.2 upon 22.4, and number of moles of Cl2 will be 0.5 or half mole. Yes or no?
Yes, sir.
Now, there is a very simple question I'm gonna ask. If you are going to make tea and the basic needs of making tea, just let's say milk plus or water plus tea leaves is there, and you are getting tea. Now you have water in excess, but this is in limited stock. This is very limited. So what will happen after completion of this, or after ending of this tea leaves? Will you be able to make tea? Yes or no? If you are making tea for the guest and in between that your tea leaves finished, then will you be able to make tea? Yes or no?
No.
Aisha and Ravi? No.
No.
So basically there is a term in chemistry, physical chemistry, and that is your limiting reagent. Limiting reagent. Have you heard of this limiting reagent? Yes or no?
Yes, sir.
Yes, sir.
So limiting reagent, the reactant, what we call it, the reactant, which limits the product, which limits the product is called limiting reagent. And basically the product depends upon the limiting reagent, because this water you have in excess, but the tea leaves is in limited amount. So according to this limited amount, you will make or prepare tea. So basically you can see 1 mole of hydrogen react with 1 mole of Cl2. They should be equal, the ratio should be equal to get 2 mole of HCl. But when you are coming here, you can see 1 mole of H2 is here and 0.5 mole. So are you able to identify which one is limiting reagent, hydrogen or Cl2? What do you think?
Yeah, true.
Cl2, because it is lesser in amount. They should be in equal proportion, 1:1. But here you can see hydrogen is 1, but Cl2 is 0.5. It should be 1. So it is lesser in quantity. That's why this is your limiting reagent, and the product will formed on the basis of limiting reagent, not on the basis of the one which is in excess. So this is in excess and this is your limiting reagent. So you can see one can give 2 mole. So 0.5 mole can give 1 mole of HCl. Yes or no? Are you getting my point, Aisha, Rabia?
So can you explain again?
Yes, I can explain again. I'm going to take another example. I'm going to write somewhere else. Let's say, uh, should I take another example like for tea leaves? Do you know this is your sandwich? So I'm going to prepare a very basic sandwich. You have 2 bread and you are going to put 1 cheese between 2 bread and you will get 1 sandwich. Yes or no? Aisha, Rabia? Now see, if I'm going to take 10 bread and 5 cheese, how many sandwich I will be able to make? How many sandwich I will be able to make?
5.
5 sandwich, Aisha?
Yes, sir.
Are you able to understand this? You can see 2 bread
Yes, sir.
required 1 cheese to get 1 sandwich. 2 bread, 1 cheese. So 10 bread, 5 cheese, and you will get 5 sandwich. Are you getting my point? You can
Yes,
compare
sir.
this 2:1 or 1:1. Or here you can see 10:5, that is 2:1, and 5:5, that is 1:1. Now, if I'm gonna take 30 bread and 20 cheese, can any one of you answer me which one of the following between these are limiting reagent, and what will be the number of sandwich that you will get? What do you think? Will you be able to answer? You just need to do the unitary method. I'm gonna give you a very easy trick to find LR. Whatever is the number of moles given in the question, whatever is the number of moles given in the question, you are going to take the ratio of this number of moles of the given in the question to the number of moles in the reaction. You can see here it is 20/1, and here it is 30/2. The one which is lesser in quantity, the one which is lesser in this ratio, the one which is lesser in this ratio will be the one which is in excess. You can see 20/1 is 20, and here it will be 15. So basically this ratio is greater than this, so the lesser one will be your limiting reagent. Are you getting my point? This is how you can easily calculate the limiting reagent. You can easily recognize the limiting reagent. Are you getting my point, Aisha and Rabia?
Yes.
Now, what you need to do is very simple. Now you know that the product formation will depend upon the limiting reagent, not on the one which is in excess. Are you getting my point, Aisha, Rabia?
Yes, sir.
So
Yes, sir.
what you need to do, just compare the one which is the limiting reagent. So you can see 2 bread gives you 1 sandwich. So I can write 2 bread gives you 1 sandwich. So 1 bread gives you 1/2 sandwich. And what actually we have 30 bread. So for 30 bread, you will get 1/2 into 30 sandwich, and you will get 15 sandwich. So the answer here will be 15, and the limiting reagent is your bread. Are you getting my point?
Yes, sir.
Now again, I'm gonna take that example and explain to you. Just wait a minute. Now you just need to write the reaction first. So H2 react with Cl2 to give you 2HCl. Now you can see 1 mole of this react with, this is the general equation that give you 2 mole of HCl. Now what we have actually is very simple. This is your 22.4 liter. This is your 11.2 liter. So I'm going to write directly. This is your 1 mole and this is your 0.5 mole. And you need to calculate what will be the number of moles of HCl. So whenever all the reactants moles are given, then you need to calculate the one which is limiting reagent. So how you are going to do? This is the question's number of moles. And now in order to calculate the limiting reagent, you can divide this with the number of moles this in the equation. This is 1:1, and again this 0.5 upon what is the number of moles here? 1. Balance, it should be balanced. So you can see this one is the larger one. So the one which is lesser or smaller will be the limiting reagent. That means this is your limiting reagent. Now one thing is important, that is the product formation will take place according to the limiting reagent. You are not going to compare with this because it will be wrong. Since it is in excess, that means it will not react completely. There will be some amount that will be left in the reaction. That's why we are going to compare this with limiting reagent. So you can see 1 mole will give 2 moles. So 0.5 mole will give 1 mole. Double of this. Are you getting my point? 1 mole of this will give 2 mole. So half mole will give 1 mole of HCl. Have you got it, Aisha?
Yes.
So this is how we do. Please do it. Let me know when you are done with this.
Done, sir.
Very. Now, which chapter is going on in your class? Aisha and Rabia, which chapter is going on in your class? Solution or
Sir,
Sir,
in the
are you talking
school,
about
what did you say?
sir, are you talking about in school or in the
Uh,
tuition, the lab?
in the tuition, in coaching, in Learnivio.
For me, it's chemical kinetics.
sir, it's haloalkanes from
Okay. I'm just gonna note it down. Is it the first chapter or you have completed some of the chapters?
It is chemical kinetics. It's the fourth chapter, and we completed second and third since first is deleted.
Okay, solution and electrochemistry is done, right?
Yes, sir.
Chemical kinetics is going on. Okay. What about you, Aisha? Have you started with this haloalkanes or
we started with haloalkanes. I joined late, so I got the recordings of solution.
okay, haloalkanes and haloarenes you going on, right?
Yes, sir.
You have got the lecture of solution and
Only solutions.
the solution. Okay. Let me know the answer of this. Also, in the have you seen any lecture videos of the this what we say solution, Aisha? Any of
Yes,
the
sir.
lecture for okay. Please do this question and let me know. Let me know if you are not able to solve this. Should I explain or you can do it?
You can explain.
Okay, see. Basically, the question is very easy. If you have studied this solution chapter or class 11th first chapter, so you can see number of molecules are given of urea present in 100 ml of solution. That means volume is given, concentration of solution, and the unit is m. M that is stand for molarity, and molarity has a formula. Number of moles of solute, number of moles of solute upon volume of solution in liter, volume of solution in liters. Now you can see number of moles of solute, that is given mass upon molar mass, as well as given volume upon molar volume upon as well as given number of particles. Since given number of particle is given, so I'm going to use this given number of particle upon Avogadro number, that is 6.022 or 6.02 into 10 raised to the power 23. So this is the value of number of moles of solute upon volume of solution, that is 100 ml divided by 1000. So so always whenever you are going to use this formula molarity, you are going to put the volume in liter. So that's why I divided it by 1000, and accordingly you can cancel this 10101010 will be cancelled, and then you can say this and this will be cancelled, and there will be 10 raised to the power minus 3, or you can write 1 upon 10 raised to the power 3 upon 1 upon 10. So this will be written as, and this 10 will be here, and then you can write 10 raised to the power minus 2, and that means 0.01 m. So the answer will be A. Are you getting my point, both of you?
Yes, sir.
Okay, please do write it. Let me know when you are done with this.
Done, sir.
Very good. Now I'm going to give you a very easy question, and let's see. Then I'm going to discuss about the next class, what actually we are going to do. Yeah, let me know when you're done with this.
D.
Which one is the answer? See, we need to calculate the number of water molecules is maximum in 1.8 gram. 18 molecules, that is directly given. 1.8 gram. You can see number of moles you need to calculate 1.8 divided by 18. So that will be 0.1 mole. And to calculate number of molecules, you are going to multiply it with Na. Then the next one is 1 mole. So for the number of moles, molecules, it will be 1 into Na. Now for the last one, it is given 18 moles directly. So it will be 18 into Na. So what do you think? Which one will be the 18 molecules directly given for the first option? Second option is 0.1 into Na. The third option is 1 into Na and 18 into Na. Which one is greater?
14. D.
D. So the answer is Rabia D. Is that clear?
Yes, sir.
Okay, so first of all, this class is especially for NEET preparation. So most probably in this class, we are going to have questions. But I will also give theoretical or the concept in which you will face problem or having doubt. I will clear that in the first place, then we will go for the question. Now I'm going to start this in the next class. That means on coming Sunday that we have class, and that class will be for I think 1.5 an hour, for 1.5 hours. And in that class, I'm gonna start, I will directly gonna ask questions from concentration terms, solubility, Henry's law, Raoult's law, ideal and non-ideal solutions. So Rabi, I think you have studied these topics already, right? And also did questions.
Yes, sir.
Aisha, how many topics you have covered from this topic, from this?
So almost all.
Almost all. So I would suggest both of you to go through this concept and solve as much question as you can. And then I'm gonna take some important questions like PYQs, and some questions will be there, which is very important. So in the next class, we are going to directly jump on this and we'll start solving the question. And any one of these 5 topics, if you have doubt, you can ask me right now, or you can ask me on Sunday before giving questions. Okay, Aisha and Rabia.
Yes, sir.
Yes.
So